So in this question, we're going to refer back to an older homework question. And so I'm just going to jot some numbers down from the question we're referring back to. And that is that there is a path, and the total length of the path is 1 kilometer, or 1,000 meters. So that would be the delta x. And we know that this woman runs down the path in one direction with a speed of 4 meters per second, and then she runs back with a speed of 2 meters per second. And we already did the calculations in that problem that the time it takes her to run down the path at 4 meters per second is 250 seconds, and the time it takes her to run back is 500 seconds, for a total time of 750 seconds. Now, at some point in her path, it also says she stops for 1 minute, but that doesn't mean we're going to add the minute onto the 750 seconds to bring it up to 810 seconds. That minute is already included in the time that she spends in motion. So these graphs should go from 0 up to 750. So what you should do to make the graph as large as possible is count the number of vertical lines that you have going along, so see what kind of time interval we can put on the x-axis. You don't count the first line because that's 0, but if you count all these remaining vertical lines, there are a total of 25 of them. And if you take 750 and divide it by 25, you get 30. So that means that each of these lines should be spaced 30 seconds apart, which makes sense because now that means that two lines are 60 seconds or 1 minute apart. So let's go ahead and label the axis on the graph. Okay, so there's the labeled axis. And I kind of took a lazy route, and instead of putting things here in seconds and going up to 750 seconds, I just converted it into minutes. 750 seconds is about 12 and a half minutes. So I just did minutes with 60 seconds or 1 minute for every other line up to, this is 12, so 12 and a half minutes, or 750 seconds would be right here. And I also went ahead and labeled the x-axis with every horizontal line being 100 meters up to the total furthest away position is 1,000 meters, or 1 kilometer, before she turns around and comes back to her starting point. Okay, so let's go ahead and plot some points on this graph. We know that at 250 seconds, she had already reached the end of the path, so she was 1,000 meters away. 250 seconds is just over 4 minutes, since 4 minutes is 240 seconds. So I'm going to go on the graph to just past the 4 minute mark, and I want to put a dot at 1,000 meters. So that'll be that right there. And I could draw a straight line going up to the dot, just like this, if I wanted to. But it doesn't say that she was running at a constant speed. It just says she had an average speed. But it'll make things easier on the next graph if we try to stick to a constant speed as much as possible. Otherwise, the velocity graph is going to be kind of going a little crazy. But the one other thing to remember is that it says we have to include a 1 minute time interval somewhere on the graph. That means that she stopped for just 1 minute. So, and we can put that on either side of the graph, either going up or coming back to where she started. So, and it can be anywhere, just not at the very end, because if you read the question, it says when she gets to the end, she immediately turns around and jogs back to where she started. So you should not really have the 1 minute time interval up in this top region right here. So I'm just going to pick an arbitrary point on the graph. Let's say maybe at the 2 to 3 minute mark at 600 meters. So just put a horizontal line. Remember, this is totally random. I'm choosing this as long as it's a 1 minute time where there's a horizontal slope, meaning she stopped. And then I can just connect the 0, 0 point up to one end of that line and the other end of that line up to that point. And now what you should realize about this line is that even though her average speed was 4 meters per second, these two lines do not have slopes of 4 meters per second. If I'd have drawn a straight line from here all the way up to here, that would have a slope of 4 meters per second. But these two individual slopes are actually a little bit greater than 4 meters per second because they have to average in with this 0 meters per second for 1 minute to give a total average speed of 4 meters per second. The part of the graph where she's returning back to where she started, this is much easier because we don't have to include another 1 minute time interval. So we can just say that at 12.5 minutes, or 750 seconds, she was back right where she started. So put a dot right down the end of the graph. And then we just have to connect the 1,000 meter point all the way down to that point. So now let's draw the graph of velocity versus time. And I will need to know what the velocities are, the slopes of each part of the position versus time graph. So if I calculate the slope of this part right here, it's going to be 600 meters is the rise, divided by, and let's put this back into seconds, so 2 minutes is 120 seconds. So 600 meters divided by 120 seconds is 5 meters per second. So I'll write that on the graph. This one has a slope of 5 meters per second. This part's horizontal, so I know that's going to be the 0 meters per second. And then the next part, if you calculate the slope from the 600 to 1,000, that's a rise of 400 meters. And that was in a time of, it went from the, looks like about 170 seconds altogether. So 400 meters divided by 170 seconds, that one is a slope of 5.7-ish meters per second. And you might have totally different answers for these slopes, depending on where you drew this horizontal part of no velocity. Like if you drew it much further up here, you could have completely different slopes than what I have. So there are tons of right answers to this question, as long as you calculate the slopes of the two parts you have. Or you may even have her 0 meter per second thing somewhere on this side of the graph instead of over here, and that's fine too. It just said somewhere in her motion she has to be stopped for 1 minute. And the downward slope, that's the easy one, because since we don't have any stopping point, that is going to be 2 meters per second, but negative, because we're talking about velocity now. So negative 2 meters per second for the slope in that part of the graph. So let's go ahead and label the axes on the velocity versus time graph. Okay, so there's the velocity graph labeled, and I don't know how well you can read this, but the vertical axis goes from -4 up to +6, and that's in meters per second, and the horizontal axis, the time in minutes, is exactly the same as what we had on this graph, because I want these two graphs to be consistent, perfectly lined up with each other. So the velocity graph, because it's sections of what we're making as just constant velocities, I'm going to have all horizontal lines. So the first horizontal line for those first 2 minutes will be at 5 meters per second. So I can put the line right here. Next line for 1 minute is at 0 meters per second. That's from the 2 to 3 minute mark. Next line is at 5.7 meters per second, so that's really close to 6, and that's for just past the 4 minute mark. So roughly something like that. I know this is not looking pretty, but it doesn't really matter. And the last part is -2 meters per second all the way to the end. So we'll go down to here and just draw at -2 the horizontal line all the way to the end. And then if you want, you can just connect them with the vertical connectors just to make it a continuous graph. Alright, part C, we're going to draw and label a motion map for the woman, and we're going to choose a time interval. I think in this case, let's just choose a time interval of 1 minute. That way we have, you said this graph was about 12.5 minutes. So she spends just over 4 minutes going in the positive direction, and one of those minutes she stopped, and then she spends about 8 minutes going in the negative direction back to where she started. So what the motion map will look like will be, we should have a total of 4 dots going to the right, except one of those dots is stacked because she was stopped for the minute, and then we should have 8 dots with the arrows going in the reverse direction. So it looks something like this. We'll do dot number 1 with an arrow, dot number 2 with an arrow, dot number 3, this is the dot where she stopped for a minute, so that'll just be a dot, and then stacked directly above that will be dot number 4 with an arrow. This is going from the 0 meter mark right here up to the 1,000 meter mark. And now we want to go back to the 0 meter mark with over the course of a total of about 8 minutes. So we just want to try to get, as best as we can, doesn't have to be perfect, 8 dots going back and ending up where we started. So it will look like, let's do about 1, 2, 3, 4, 5, 6, 7, 8. When we put the arrows on them, they should all be the same length arrow. 3, 4, 5, 6, 7, 8. Back to where we started.